over that question. So everyone's at this point. We're all going to start working on some problems, and I'll.
Well, is there going to be something like that on the test?
Yes. Just 1 minute. Okay. So this is what we're going to do today. We're going to have several problems. And I'm not going to tell you ahead of time which technique to use or any of those sorts of things. It's up to you to figure it out. So here's the first problem. The Health and Safety Board recommends at most 4 hours of TV each day. You think people watch more. You survey 130 people who watch an average of 4.5 hours a day with a standard deviation of 1.7. What can you conclude, and at what confidence? So start working on this, and then we'll talk about it in a couple minutes. Okay, let's talk about this first problem then. What do we do? Okay. First bit HOH1. Good. So tell me. I'm just listening. Whoa. Okay. Good. Okay. 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 So standard deviation X bar, how should I write that down? Okay. And what is that? Okay. And now, sorry? Okay. So is it normal? Yes, it's normal. Everyone agree? Do what part? Okay. Okay. What's the first thing you need to check? Okay. So, right. Is this question talking about average? So, mu stands for a mean, and p stands for a proportion. Is this question about means, or is it about proportions? Yeah. So it's about means. Well, yeah, exactly. What are they giving to you? That's a good question. What's being given and what's being asked? Right. The question is the mean greater than 4? And where is that question being asked in this question? What words in this question are saying that? What words in this question represent the claim? You think people watch more. So, more than what? Well, that's clear from the previous sentence. Right. So in other words, you think the average is more than 4. You think that mu is greater than 4. That's your claim. So Benny, you made the point, but they tell you the average. What average are you being told here? 4.5. Now, is 4.5, are you being told that that is mu? It's what? It's x bar. Now, what's the difference between mu and x bar? Right. Mu is the mean of the population. X bar is the mean of the sample. Remember what we said really weeks ago about the idea behind what we're doing. The idea is, or actually, heck, think back to the first week. Why do people take a survey? If I go out and ask 20 people a question, it's not because I want to know what those 20 people think. It's because I want to know what everybody thinks. But I can't ask everybody. I can only ask those 20 people. That's all I got time for. That's the idea. I want to be able to say something about the population, which in this case is mu. And I'm going to try to find, and the best I can do is come up with a sample which gives me x bar. So based on x bar, I'm going to do all these calculations, and in the end I'm going to try to say something about mu. So even though they're both a mean, philosophically they're completely different. Philosophically, one is, in this case, I went out and asked 130 people. That's x bar. But what I want is everybody. All, whatever, 300 million people in the United States. That's mu. Do you understand the distinction?
I understand the distinction.
Okay. Okay.
Okay.
So one thing you have to do is you have to get yourself ready to be aware that in one case we're talking about a population, and one case we're talking about a sample, and which is which. You have to be ready to look for that distinction. Okay. So that's a major bit. So, oh yeah, Pilar. Okay. When do you use NP? Well, minus P is greater than 10. Yeah. There's a P in there, so it's telling you that it's for proportions. Is this problem about proportions? No. Okay. Well, that is one test. However, in this problem, before you check if n is greater than 30, there's something you have to check first. And this is what we went over 2 lessons ago. When do you use the t-distribution automatically? Right. When you don't have sigma and you have s. Now the standard deviation that we're given in this problem, is this sigma or is this s? Yeah. How do you know? The standard deviation is the standard deviation that we're given is 1.7. Where does it come from? Let's read the question. You survey 130 people who watch an average of 4.5 hours a day with a standard deviation of 1.7. Where does the standard deviation of 1.7 come from? It comes from the sample. So is this sigma or is this s? This is s. So which distribution are you going to use? You're going to use the t-distribution. So this actually goes back to what Benny was saying, but in a way that we've only recently begun to talk about. We've been talking for quite a while about whether the mean comes from the population or whether the mean comes from the sample. Now we also have to remember to think about the standard deviation. Does that come from the population? That's sigma. Or does it come from the sample? That's s. So if you read this question, remembering that you have to figure that out, it's fairly obvious. If you just assume that it's sigma, then you'll go wrong. So we have to go back and fix this. This is not sigma x bar, this is S x bar. And the problem tells us, let me write this on the side, that S is 1.7. If you work this problem out using sigma, you will get partial credit on an exam, for example. It would either say it has to indicate that it's sigma. So what does that mean? It would have to say sigma equals 2.4, or it would say the standard deviation of the population is known to be 2.4. Right. So in this case, it doesn't say the standard deviation of the sample is 1.7, but just we're reading English here, so we have to understand what English means. That sentence is about the sample. Therefore, all the information in that sentence pertains to information about the sample. Okay. So, next. Sorry? Now what? Everyone. Okay. So we draw the picture, and how do we label this? The 0 in the middle for what? What else? And what else? Okay. What was that? 3 point what? 3583? Three five 35? Okay. Okay, and? Okay, how do I do that? Go to status. Okay. Okay, now what? Okay. So what are the degrees of freedom? Okay. And how do we get 129? Okay, now what else do we put in? Okay. So these are your numbers, so what do we fill in? Okay. And then it said to the left was 0.9995. Okay. Okay. So now what? State your conclusion, which is? That what? Okay. Yes. You can say it both of those ways. Yeah. Okay. It's a different distribution. So the question is, when do we use, well, the z distribution is the normal distribution, and then when do we use a t distribution? So, well, in order to be using the normal distribution, what has to be the case? We have to have sigma, and then one of two things has to be true. If the population is normal, then your distribution is normal. And that, by the way, is something a lot of people missed on the homework. So, y'all, if the population is normal, once you have sigma, if the population is normal, then the distribution for x bar is also normal. And it does not matter how big your sample size is at that point. Now, if you have sigma, then if n is greater than 30, if n is greater than or equal to 30, that also guarantees that x bar is normal. But the first thing you need to check is, do I have sigma? Which many of you forgot to do for this problem. The answer is very similar. Remember what I said when we first learned what the t-distribution was. I said, first of all, it's very similar to the normal distribution. That's the first thing. And the second thing is, the bigger your n is, the closer that the t and z distribution becomes. Now, of course, what I could do is I could give you a smaller n, and I could do some things so that the difference would be quite different. So the answer would be quite different. I didn't do that in this problem, but trust me, I could, and I might. Yeah, Tamara, go ahead. Well, once we have the t-score, we can either use Excel or StatDisk. Someone said use StatDisk, so I did it. Go to the t-distribution button, fill in the information, and it tells you the areas. So, or we could use Excel, and the command in Excel is tdist.
Now, Excel gives you the area to the yes?
Excel, yes. So as I mentioned, when you use tdist in Excel, it gives you the area in the tail, or tails, if you ask for two tails. Okay, when do you have two tails? When h1 says not equals. Okay. When h1 is not equals. Like actually I think the last problem we did, or the problem from homework. Magdalena, question.
Yeah, I was
going to ask you mean the tdist command in Excel? Tdist always gives you the area in the tail, or tails. Yeah. Right. It's actually one of the for t-distribution. I pretty much always use StatDisk because it's clear. Yeah. That's part. Are you talking about using Excel? Okay. So when you're using, let me just show you that. When you're using Excel, so let's actually show how this would work using Excel. Equals tdist, and when you type that, what does it want? First, it wants an x, by which it really means t. So that's 3.3535. Then you have to put the degrees of freedom, which is 129. Then you have to put the tails. Now what it's asking for is how many tails do you have? So how many tails do we have? One tail. So you put in one tail, and it tells you the area in one tail. Now, alternately, we could go back and put two tails, and then it would tell me the area that's in two tails. But that's not for this problem, so I didn't do that. One tail. Also, another quick word of warning: when you use Excel, you have to put in the t-value must be positive. Another reason I usually just use StatDisk for a t-distribution. Okay. Damara question. Okay. Okay, any other questions? Alright. So, I clean that one up. Okay. Let's see. Okay, so why don't y'all work on this one? You need to know if Proposition 285, which is something that people vote on a ballot, will pass with 2/3 of the vote. You survey 200 people and 141 say yes. What can you conclude and at what confidence? Okay, work it out. Okay, so let's talk about the first problem about Prop 285. So what do you do first? Find the what? Find the claims. What are the claims? Right. So it's P equal to 2/3, but we're going to be doing all these calculations. So let's write that as a decimal. And you could write it as 0.67. That would be more familiar to us. But you know, I try to put an emphasis on being a little precise. So I'm going to write it to 4 places. And then what's H1? Okay. So, right. Magdalene and I just had this conversation. What does it mean for something to pass with 2/3 of the vote? Yeah, more than. Exactly. So greater than 0.6667. We're just gonna make it very simply greater than. Just to keep the notation straight. Yeah. Okay. So by the way, what tail is this?
The right tail.
Right tail. How do you know it's the right tail? Because greater than. Alright, next. Next. Okay. And what does that work out to be? Okay. Either way. Okay, good. And right. Is it normal? How do you know that? 44 something or other that's greater than 10, so you're good. Okay. Now, what other piece of information do we have that we're going to need?
Proportion of the thing.
Right. And that's p hat, and what's p hat?
41 divided by 200. 0.7.
Okay. Antonio, further question, or was that it? Oh. Next. Okay. Yeah, Maya. Well, sooner or later you gotta find p hat. So we just did it sooner. Okay. So what do we do now? And okay, what else? Right. And how do we label that on the left side? These are p hat values. Okay, what else? Okay. And what does that work out to be, anybody? 1.0542, is that good? For the z-score? Yes, no? Alright. So with it, no one strongly objecting, I'll put that down. And Antonia, what do we do now? What do we do now? Now that we found the z-score, what do we do? Okay. Oh. Alright, so we've got disputation, so I gotta check it. Alright. 0.705 minus 0.6667 divided by 0.0333. 1.1502. Alright, z-score fixed. Antonia says put it into Excel. So equals norm s dist 1.1502 0.8750. And then to find the area on the other side, what do we do? 1 minus. Which will give you 0.1250. And now what? And what's the conclusion, somebody? Okay. There we go. So 0.8750 or 87.50% confident that Prop 285 will pass with 2/3 of the vote. Or you could say reject HO and accept H1 with 0.8750 confidence. You could also say your p-value is 0.1250. So what would you conclude at 95% confidence? Do not reject HO, accept H1. Exactly. Because do we have 95% confidence? No, we don't. Right. Okay.